Um, Hi ma'am, myself Annapurna S. I'm going to explain about microprocessor scheduling. Microprocessor scheduling is important because it enables computer system to perform multiple tasks simultaneously, which can greatly improve overall system performance and efficiency. In multiprocessor scheduling, multi CPUs are or multiple CPUs are available and hence load scheduling sharing becomes possible. However, multiple processor scheduling is more complex as compared to single processor scheduling. Multiprocessor scheduling's importance. Multiprocessor scheduling is important because it enables a computer system to perform multiple tasks simultaneously, which can greatly improve overall system performance and efficiency. A multiprocessor is a system that has more than one processor but shares the same memory, bus, input or output devices. In multiprocessor scheduling, more than one processor or CPUs share the load, handle, and execution of process will be smoothly. Approaches to multiprocessor scheduling. One approach is when all the scheduling decisions and input or output processing are handled by a single processor, which is called the master server, and the other processor executes only the user code. This is simple and reduces the need of data sharing. This entire scenario is called as asymmetric multiprocessor. A second approach uses symmetric multiprocessor where each processor is self-scheduling. All processors may be in a common ready queue or each processor have its own private queue for ready processor. As explained in approach to multiprocessing scheduling, types of multiprocessor schedulings are symmetric and asymmetric multiprocessor. Symmetric multiprocessors are scheduling system of the processors are self-scheduling. The scheduler of each processor checks the ready queue and selects the process to execute. Each of the processor works on the same copy of the operating system, communicates with each other. Asymmetric multiprocessor. In asymmetric multiprocessor scheduling, there is a master server and the rest of them are slave servers. The master server handles all the scheduling processes and input-output processor, and the slave servers handles the user processes. If the master server goes down, the whole system comes to the halt. However, if one of the slave server goes down, the rest of the system keeps working. And the other topic of multiprocessing scheduling are process affinity. A process affinity is an affinity of for a processor on which it runs. This is called as processor affinity. When a process runs on a processor, the data accessed by the process most recently is populated in the cache memory of this processor. The following data access called by the processor are often satisfied by the cache memory. The avoid the cost of invalidating and repopulating the cache memory, the migration of processes from one processor to another is avoided. The types of affinity process affinities are soft affinity and hard affinity. Soft affinity um, is a is an operating system as a policy of attempting to keep a process running on the same processor but not guaranteed it will do so. This situation is called as a soft affinity, and hard affinity allows a processor to specify a subset of processor on which it may run. Some systems like Linux implements soft affinity but also provide some system calls like schedule set affinity function that supports hard affinity. And another topic of multiprocessor scheduling is load balancing. In multiprocessor system, all processes may not have the same workload. Some may have a long ready queue while other may be sitting idle. To solve this problem, load balancing comes into the picture. Load balancing is the phenomenon of distributing workload so that the processor have an even workload in a symmetric multiprocessor system. There are two ways to solve this load balancing, that are push migration and pull migration. Uh, Push migration, we can um, give it this as a task routinely check the load on each processor, and if it finds an imbalance, then it evenly distributed loads on each processor by moving the processes from overloaded to idle or less busy processor. Pull migration. Pull migration occurs when an idle processor pulls on waiting task from busy processor for its execution. Then the total conclusion of multiprocessor is uh, it is a processing system that has more than one processor but shares the same memory, like bus, memory, and input-output devices. Input processor scheduling more than one processor shares the load to handle the execution of processor smoothly, and it has two types like symmetric multiprocessor and asymmetric multiprocessor, and it has a process affinity for a processor on which it runs is called as processor affinity. Thank you.